Welcome to the Michael Shermer Show. I'm your host, Michael Shermer. My guest today is Avi Loeb, but before I introduce him, let me tell you about our sponsor, the Great Courses Plus app. Here it is, Great Courses. You just touch on it and it opens right up. I had started listening to this course months ago, and then I just picked it up again the other day. I'd gotten through 14 lectures on understanding the U.S. government. You can see why that's kind of a relevant topic these days in the last year. And so the beauty of this system is that you can access any of hundreds of courses, and in each of those there are dozens of lectures, and you can hop from one course to the other, from one lecture to the other. You don't even have to finish the lectures if you find them not particularly interesting, or you can do a deeper dive into that particular subject with some other course. I got all the way up to 15, How Americans Became So Polarized. That seems kind of relevant these days. Anyway, I love this system because I consume a lot of content online, and I think so should you. It's a great way to grow and learn as a person, keep your brain stimulated. And so here's the deal. By accessing thegreatcoursesplus.com/Shermer, you get $30 off the annual fee, and you get a free trial as well, and it comes out to less than $10 a month. It's a great deal. So go to thegreatcoursesplus.com/Shermer. Okay. My guest today is Avi Loeb. He is the former chair of the astronomy department at Harvard University and the founding director of Harvard's Black Hole Initiative and director for the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics. He also chairs the board on physics and astronomy of the National Academies and the advisory board for the Breakthrough Starshot Project, and is a member of the President's Council of Advisors on Science and Technology. His new book that we discussed, you've surely seen it because everybody's talking about it. It's on the bestseller list now, one of the best-selling books in America. It's called Extraterrestrial, The First Sign of Intelligent Life Beyond Earth. Now, as you'll hear, I push him on that rather bold claim, and he backs off that immediately by saying, I didn't write the title or subtitle. That was the publisher. Yeah, but you got to sign off. I'm an author. I know you can always object. And most publishers do have the final word on the cover and the title and subtitle, but you can push back. And in my opinion, he has made the epistemological step into saying that we have detected a sign of extraterrestrial intelligence. Now, as you'll hear in the conversation, he does back that off quite a bit. And he does in the book, for the most part, show the fact that most of his colleagues don't agree with him on that, and that the evidence is not clear. So we get into all that. It starts off as a kind of a difficult conversation. He's been doing so much media. He's probably tired of being pushed on these points, but I kind of came around it from a philosophy of science perspective. He wouldn't let me read my section on Galileo, but it was he who brought up Galileo, not only in the conversation, but pretty much every interview he gives. And Galileo makes several appearances in the book in the context of, well, in my opinion, what Galileo did in looking through the telescope and the Vatican astronomers did in response by refusing to look through the telescope is his sense that his colleagues don't want to see what he can see. The problem is it isn't clear what you're looking at. And so my analogy with Galileo, and he did finally let me get in the story of Galileo and why Galileo got it wrong on Saturn. The point of that story is not that he was wrong. Scientists are always wrong about things. That's not it. It's why he was wrong. So I'm going to read this section from The Believing Brain in the chapter on geographies of belief. After observing Saturn, the most distant planet of his day, through his tiny telescope, Galileo wrote to his astronomical colleague, Johannes Kepler, I have observed that the farthest planet is threefold. He then explained what he meant. This is to say that to my very great amazement, Saturn was seen to me to be not a single star, but three together, which almost touch each other. He saw Saturn not as a planet with rings as we see it today in even the tiniest of home telescopes, but as one large sphere surrounded by two smaller spheres, thus accounting for its oblong shape. Here's a picture of what he, from his own book, of what he thinks he saw. There it is, that kind of oblong shape, or the one with the two ears or two little planets going around the big planet. That's how he interpreted it. Okay, continuing the story. Why did Galileo, champion of observation and induction, make this mistake? Having praised empiricism as the sine qua non of science, we must now admit its limitative effects. Galileo's error is instructive for an understanding of the interplay of data and theory, and when it came to Saturn, Galileo lacked them both. Data. Saturn is twice as far away as Jupiter, thus what few photons of light there were streaming through the cloudy glass in his little tube made resolution of the rings problematic at best. Theory. There was no theory of planetary rings. It is at this intersection of non-existent theory and nebulous data that the power of belief is at its zenith and the mind fills in the blanks. Like Columbus before him, Galileo went to his grave believing not what his eyes actually saw, but what his model of the world told him he was seeing. It was literally a case of, I wouldn't have seen it if I hadn't believed it. Galileo cannot see the rings of Saturn, either directly or theoretically, but he certainly saw something, and herein lies the problem. I have observed that the farthest planet is threefold. Oh yeah? As the late Harvard evolutionary theorist and historian of science Stephen Jay Gould noted in his insightful commentary on the Galileo-Saturn affair, he does not advocate his solution by stating, I conjecture, I hypothesize, I infer, or it seems to me that the best interpretation. Instead, he boldly writes, observavi, I have observed. No other word could capture with such terseness and accuracy the major change in concept and procedure, not to mention ethical evaluation, that marked the transition to what we call modern science. Now, in time, it was figured out what Saturn's rings were. This was conducted by Christian Huygens, and in his book, he pictured what is essentially a catalog of errors about what errors. So, number one up there, this is Galileo's hypothesis of what it was. It was a giant planet with two smaller planets or moons or three stars. Anyway, whatever he described it as was not, and it wasn't until, again, Huygens figured it out and put it all into motion in this illustration here, which puts the sun at the center instead of the Earth. It puts the orbits of planets in ellipses rather than circles. And it shows the perception of Saturn at different times of the year at different angles, such that the rings are either almost disappearing because they're edge on, or they're more oblate on their side, and they make a much bigger image in the crummy little telescopes they were looking at. And this, I think, is analogous to what I think is going on with Avi's object. There is that you can't quite make out what it is. We have no theories of what would be the equivalent of Saturn's rings in the either the outer solar system, but it appears to be from other solar systems, other stellar systems. So we just don't know. And it's one thing to say, I don't know. It's quite another to say, I have observed. Avi doesn't go so far as to say, I have observed ET. No, he does not say that. But he does strongly infer that's what we're looking at. And okay, fair enough, put it out there, but don't be surprised when people push back on that, because it isn't that clear. Anyway, that's my opinion of it. I love the book. The subject is, super interesting. It's one of the most interesting subjects you can study, the possibility of extraterrestrial intelligence. So with that, enjoy this conversation with Avi Loeb. I see your book made it was in Saturday's Wall Street Journal bestseller list, and I heard that it's going to be on the New York Times this coming week, I think. In any case, congratulations on that.
It's already, yeah. So within the first week of its appearance after publication, it was already ranked in the New York Times bestseller list number 7, and if you include the ebook, it's number 6. Sort of sandwich between Michelle and Barack Obama.
That's a good place to be. Well, I mean, I think it's a testimony to the public interest in the subject of extraterrestrials.
I agree. I agree. I should say that my publicist, in the UK, he was saying, good work, Avi, in terms of attending to the public's interest. And I told him, look, it's not me, my efforts that make it so popular. It's the public's interest in this subject. It's basically the content of the book that makes it so appealing. And I would advocate, by the way, I told him I would advocate exactly the same message even if it was not popular. So I basically deliver a message, and I think the message is the thing that the public is cares about and is interested in. And it's not so much the number of books being sold that it's the message that appeals to the public.
Yeah. Well, that's right. And I think ever since Sagan made it acceptable scientifically to study the possibility of extraterrestrial intelligences, that kind of opened up the door for that. For people like you to come along and you're not some crank out there saying UFOs are real. You're the head of Harvard's astronomy department, and you're claiming that there's evidence for extraterrestrial debris, I guess you'd call it. This. Why don't we start there? Why don't you, for the 3 people on Earth who don't know what this is?
But
tell
you
us
said
about
several
it.
things, and I just wanted to first of all, put things in perspective. So Carl Sagan was an assistant professor, a junior faculty at the Harvard Astronomy Department many decades before I came along. And he was denied tenure. He was basically told that he will not get tenure. And, partly it's based on his interest. I was not around at that time. I'm not sure exactly the circumstances. He left to Cornell, where he was tenured. I arrived later, decades later. I was mostly interested in cosmology, the study of the universe, and in black holes. That has been my focus. But in recent years, I started getting interested in the search for life. And then this object came along. So this is Oumuamua. And the reason I mentioned this background is I wrote more than 800 papers, and I published 8 books or so, including this one that just came out. And, and I didn't have an agenda. This is not a subject that I promoted my entire life. And there came along this object, and it looked weird. And I applied the same approach to the discussion about the anomalies of Oumuamua as I did when anomalies were discovered in terms of the temperature of hydrogen in the early universe being too low. And then I tried to explain it in terms of the dark matter having some small electric charge, and in exactly the same spirit. Now, it so happens that the scientific community is perfectly fine with discussing dark matter having a small charge, even though that's a speculation, whereas discussing a possible technological relic requires extraordinary evidence to even put it on the table as a possibility, to even discuss it openly, scientifically, as we discuss any other option. And to me, something is distorted in the current scientific culture. And I say it because I came from many other fields,
Yeah.
And moreover, I see the bigger picture of physics, where you see that in theoretical physics right now, at this time, there are communities working on concepts such as extra dimensions, string theory, supersymmetry, the multiverse, concepts that have no connection to evidence, no connection to experimental verification, not even by now, but even in the foreseeable future, yet they are considered as part of the mainstream. Awards are being given to people working on these, and some of the people in those fields claim that they carry the torch of physics forward, whereas in fact we don't even know if these concepts have any resemblance to reality. So you have that culture at the same time as people ridiculing a discussion about the search for technological signatures, which, by the way, we know that we are producing. That's point number 1. We exist. And second point is, half of the sun-like stars are known, from the Kepler satellite data. Half, plus or minus 30%, have an Earth-sized planet roughly at the same separation. So then you ask yourself, if you arrange for similar circumstances, why wouldn't you get similar outcomes? What could be more conservative than that? This is not speculative. It's just saying, I replicate the conditions I find in my backyard, and I expect things to be similar. Now, I'm not claiming they must be similar, but we can search for them. And the search for that is on much more robust ground than the search for extra dimensions, which we don't know if they exist. Or if you want the search for specific types of dark matter. Here is another example. We know that most of the matter in the universe is dark. We don't know what it's made of. So we are searching in the dark. And then some theories suggested, oh, maybe it's weakly interacting massive particle, maybe it's axions. And these searches are done in the laboratory, are done in the sky. They are funded at the level of hundreds of millions of dollars. And the search for technological signatures, similar to what we are producing, are funded, is funded 1,000 times less. Okay? I'm talking about a factor of 1,000. So think about it. Searching in the dark for a particle we don't know exists is funded 1,000 times more than searching for something that looks like us. How is that possible? So it shows you something is wrong in the current scientific culture. Now, let me explain one possible explanation. So these concepts of string theory, the multiverse, extra dimensions, they serve as a sandbox for people to demonstrate how smart they are. So even though these things have no verification from experiments, you can demonstrate your mathematical skills in working on anti-de Sitter space, which is not our space-time. We don't live in anti-de Sitter space. We live in de Sitter space. So people work in anti-de Sitter space because it's possible to solve some problems mathematically there. And that's a whole community doing this research, hundreds of people, part of the mainstream, completely legitimate. Nobody is raising an eyebrow. And, people popularize this study as if it's carrying the torch of physics forward. So you have that, whereas the search for technological signatures similar to ones that we produce, we sent out Voyager 1, Voyager 2, New Horizons. Why couldn't we imagine that there is equipment floating in space, some of it billions of years old and therefore dysfunctional, and we are just searching for debris? What could be more straightforward than that search? But instead, this is not funded and is being ridiculed, and you or other people require extraordinary evidence to even put this possibility on the table.
Well, no.
Why do I need to give? No, wait a second. Why do I need to give extraordinary evidence?
I will tell you.
Before this is being discussed, whereas people that consider weakly interacting massive particles for the dark matter do not need that, and they are funded for search that didn't find anything for decades.
Yeah.
So explain to me that.
Yes, I will. Okay, the subtitle of your book is The First Sign of Intelligent Life Beyond Earth. Your book is not saying we should look. Your book is claiming you found it. That's the difference, Avi. It would be like if Kip Thorne... No, hang on. Let me give you some examples. It would be like if...
But it was not true. What you said is not true. Don't judge a book by its cover. The cover was decided by the publisher. I did not decide what they put on the cover, okay? If you read the book...
I did.
And you don't judge it by its cover...
I read the book.
Read the book.
I did.
You will recognize that I'm saying that this is a plausible possibility that we should entertain and collect more evidence. We should be guided by evidence. We should not have a prejudice. We should not say it's never aliens, it's always rocks, and therefore this should not be examined. What we should say is, given Oumuamua, there is a wager saying if it is an artifact, if it is a technological artifact, the consequences are huge for our society. Therefore, let's deploy cameras within the orbit of the Earth around the sun so that next time around when an object comes in from interstellar space, we will take a photograph, a close-up photo. If you say it's never aliens, show me an alien that shakes my hand and only then I will actually fund such a search. That's the wrong attitude, because if you're not ready to search, you will never find anything. It's a self-fulfilling prophecy. Okay. And the other point I want to make, when I go to the kitchen and I find one ant, okay, I get alarmed. All I'm telling you is common sense. I get alarmed. Why do I get alarmed? Because I search only a small portion of the kitchen, and there must be a lot of ants out there. So the fact that we found Oumuamua that has 6 peculiar properties that should be explained, okay, means that it's part of a population, and there should be many more. So we search for a few years. We wait a few more years with similar search, we will find another one. If we use the Vera Rubin Observatory, which will come online in 3 years, much more sensitive, we might find one every month. My point is simple. You walk on the beach. Most of the time you see rocks that are naturally produced. Every now and then you see a plastic bottle that tells you a civilization is around. Let's search for those plastic bottles by taking a photograph so that it would be clear what this object is. Rather than, I left the seminar room after a talk given about Oumuamua, there was a colleague of mine that worked on rocks in the solar system for decades that left the room with me. And he said, Oumuamua is so weird, I wish it never existed. Now, what does that mean? I was appalled by this because in science, you are supposed to be excited when something new comes along because it may revise the way you think about reality. Instead, the mainstream astronomers feel that it takes them out of their comfort zone if they were to entertain a controversial interpretation. And so they say, forget about the details. It's a rock. I wish it never existed. My point is that actually the scientific community divides into three parts. Let me just explain. That is very important. There is the part of people that write blogs or write books on popularizing science. And if you look at their resume, you would see that they haven't written a single scientific paper over the past decade. Okay? But they are very popular among, in the public's eye. These people, I don't even read. I don't care because they are not practicing scientists. They just follow where the wind blows, where they try to maximize the number of likes they have on Twitter. And whatever they say is to maximize the number of likes on Twitter. It has nothing to do with scientific merit. I ignore those. Then you have practicing scientists. These are the people that are in the trenches. These are the soldiers that, move the battle forward and find new evidence and so forth. So in the mainstream community of scientists that are practicing, that have papers continuously, you have the bulk of the people that say, I don't I don't really know much about rocks in the solar system. It's a subject that I haven't followed much. It's probably a rock. Why get into a controversial discussion? Business as usual. That's what they say, without getting into the details of the anomalies. Then you have a group of people that really pays attention to Oumuamua's specific anomalies, that it has a disc-like shape, flat pancake shape. It was pushed by an extra force in addition to the sun's gravity. It didn't show any cometary tail. It came from a special frame of reference, which is the local standard of rest. All of these are detailed in my book. And they try to explain one or two of these anomalies. Those people always came up with something that we have never seen before, okay? For example, a hydrogen iceberg, a chunk of frozen hydrogen, such that when it evaporates, we cannot see the cometary tail because hydrogen is transparent. The problem with that is that such a chunk of hydrogen, frozen hydrogen, would not survive the journey. We showed that in a scientific paper with Tim Huang, showing that it will evaporate very quickly if it has the size of Oumuamua. And it may not form. We haven't seen something like that. Then there was a suggestion, maybe it's a very porous object that is made of dust particles, and such an object needs to have a density 100 times less than the density of air. Okay, so think about a cloud of dust 100 times less dense than air on average, being pushed by sunlight. And in my mind, when such a cloud of dust gets close to the sun the way Oumuamua was and heated to hundreds of degrees, it wouldn't survive. It doesn't have the material strength, and it wouldn't survive the journey either. And then there was, and we haven't seen anything like it before. Okay, so again, it's nothing that we have seen before. I emphasize that. The third thing was a piece that was torn apart from a bigger object passing close to a star. Okay, well, such a piece would usually be elongated, cigar-shaped, but the favored shape at the 90% confidence level, based on a detailed analysis published in December 2019 by Sergei Mashchenko, someone that is unrelated to me at all, doing his research. He argued that at the 90% confidence, this object must have been flat, pancake-shaped, disc-shaped, not cigar-shaped, at the 90% confidence. So this explanation of a tidal breakup of a bigger object doesn't hold water. And moreover, the chance of something passing close to a star is very small. So my point is simple. Those people that I greatly respect, that paid attention to the anomalies and tried to explain them from a natural origin, came up with explanations that involve something that we have never seen before. And I find each and every case that they proposed less plausible than an artificial origin. Now, if someone would come with an explanation that is a natural origin and explains all the features of Oumuamua in a way that doesn't involve small probabilities, that would be a different matter. Or if we had evidence like a photograph that shows that it's a rock, but something really unusual, that would be something different. But my point is, even if it's natural or artificial, doesn't matter. It's something new. Okay, and let's collect as much data as possible, evidence. I'm arguing for getting evidence to guide us rather than prejudice. My colleagues that say, oh no, it's never aliens, it's always rocks, say, we know the answer in advance. They are no different than the philosophers in the days of Galileo that said, we don't need to look through your telescope because we know that the sun moves around the earth. That's my point.
Okay. Thank you. That's perfect. That gives me a good launching off point. Let me tell you why extraordinary claims require extraordinary evidence. You mentioned Galileo,
okay.
and of course, this is what we call the survivor bias. That is, we highlight the people that were successful, that had theories that turned out to be true. What you're not mentioning is all the people that had theories that did not turn out to be true, like Tycho Brahe's modified solar system, where all the planets and the sun go around the Earth, but the other planets go around the sun. Okay, that turned out not to be true. So no one ever writes me to say they're the next Tycho Brahe. They always write me to say they're the next Galileo. It's almost cliche, that particular metaphor. Second, Galileo was wrong about Saturn. I don't know how much you know of that story. You probably know this story pretty well. I wrote a whole section of it in my book, The Believing Brain, about the power of, okay, so here's the problem. When your data is degraded, you can't quite make out what you're looking at. And then the mind has certain ideas that it can impose on the degraded data. That makes it much more difficult, and therefore expectations then push the degraded data into one form or the other. This is how illusions work, for example.
Well, so we agree. Example, let's get more data.
Yeah. No, I'm not arguing about. I'm not arguing. Should we, Avi? I'm not arguing. Should we be looking more? Of course we should. And all planetary scientists, would agree. Let's spend more money on science.
No, sorry. You started by saying
I don't want to get down that.
Provide the extraordinary evidence.
Avi.
This requirement for extraordinary evidence is inappropriate as a prerequisite for getting the evidence. So what is the argument? The argument is, you didn't give me extraordinary evidence, therefore it must be ordinary, therefore we don't need to get evidence. Does that make any sense?
No. That's not what I'm saying. In terms of going
forward, how do you justify the factor of 1,000? How do you justify the factor of 1,000 between the funding going?
Okay, I'm not debating that.
Dark matter sets versus technological.
That's not my concern. I agree we should fund it absolutely going forward. We're talking about a claim made now about a particular anomaly.
Yes,
right?
Okay. Wait. A claim made now.
Yeah.
Let's make progress in this discussion. Not just talk about Tycho Brahe. Who cares about it?
Well,
let's make progress.
The progress you brought up Galileo.
Suggesting make. Wait a second. I don't care about history. I'm talking about gaining knowledge, not philosophizing about what happened in the past. My point is, in order to gain knowledge, which is the premise of science, the science is not about making us look smart. It's about gaining knowledge about reality. How do we do that? By collecting evidence. Okay, so from this point forward, the most important message from Oumuamua was, it had anomalies, didn't look like a comet or an asteroid. Therefore, we should search for more of the same with pan-stars or with the Vera Rubin Observatory. Deploy cameras that can take a photograph of whatever interstellar object comes into the solar system. This is not an expensive proposition. Cameras are not expensive if you deploy them. Or planning to search to send a spacecraft when something that looks really unusual is approaching us so that we can intercept along its path. That's all. I'm very practical. I'm saying Oumuamua's wager is that if it's a technological relic, it begs us to do something about it. Therefore, we should do something about it rather than say, Tycho Brahe made a mistake. Galileo made another mistake. Therefore, you need to give me extraordinary evidence. Therefore, I don't want to even discuss it. Therefore, I would ridicule your assumption and not do anything about it, which is exactly the point being brought by the people that you are supporting. They don't want to do anything about it. They want to put blinders so that we don't check this possibility, because this possibility is being ridiculed, because this possibility is compared to Tycho Brahe's mistake. Because, I mean, who cares about history? Who cares about humans saying something to other humans? What we need to do is collect evidence. I'm advocating for being guided by evidence and not prejudice. The big problem of this subject, let me just summarize the big problem. The big problem is that everyone has an opinion, and as a result of creating so much backlash, nothing is being done. No funding, young people are ridiculed. Therefore, it's just like stepping on the grass and saying, look, the grass doesn't grow. You didn't bring me extraordinary evidence. Therefore, I shouldn't discuss it. Why didn't I bring you? Because young people are afraid they will not get jobs if they were to discuss it. And there is no funding to search for it. Therefore, you see nothing. And as a result, you can say, I see nothing, therefore there is shouldn't. So it's a self-fulfilling prophecy. And my point is that this is an acidic environment that makes no sense. The public is interested in this question. The public funds science. Scientists have an obligation to discuss this subject because they have the instruments that they can put in space, not searching for microbes. Why is searching for microbes part of the mainstream and searching for technological signatures not part of the mainstream? That makes no sense. We know that both exist on Earth, right? And we should search for both. And what is the problem in discussing it, putting it on a table as a viable possibility that we exclude or confirm based on a search? You know, there are two ways to search. There is one way to make a phone call. Okay, that's the traditional way of searching for radio signals. And for that, you need the other counterpart to be alive when the transmission takes place.
Okay, so let me make another analogy with you. Let me make another.
We cannot have a phone conversation with the Mayan culture. The Mayan culture is not around anymore. Okay, we cannot, but we can find evidence for the Mayan culture by having an archaeological dig and finding relics. And my point is, it's a completely different approach that was brought about by the discovery of the first interstellar object that looked weird, Oumuamua. It begs our attention to do an archaeological search in space and basically examine every object that enters our vicinity, our backyard, from outer space to check if it's unusual or it's natural. That's all I'm advocating. I'm saying we found the first one. It looked strange, weird, in several respects that I described in detail. You should not ignore those anomalies because there is a chance we will find a plastic bottle among all the natural rocks. If you do not allow to search for that, you're basically behaving like a caveman that is presented with a cell phone and saying the cell phone is just a shiny rock.
Okay, I agree. Let me use a more recent example then. Tabistar, Tabitha the astronomer who finds this light dip in something's passing in front of this star 1,500 light years away. Okay, that was 2015, mm-hmm. and so immediately there was press coverage all over this story because this could be a Dyson sphere or massive solar panels and so on. And part of my job is to deal with these kinds of claims. This is literally my day job. So I'm on the radio that day with the John and Jillian show here in LA with George Norrie, who's the host of AM Coast to Coast.
Yes.
You've probably been on his show. Yeah. And
immediately,
and the interest in this story was not, is it something really unusual in terms of a swarm of comets or asteroids or a broken up moon? It was only because some people thought, well, maybe it's a Dyson sphere. That would be an artifact of an intelligent civilization and so on. And so immediately the story then turns, well, what are they like? What is who like? The aliens. We haven't detected aliens. We have an anomaly.
Okay.
An anomaly is different. And now what's happened with that story? Let me finish. Avi, we have to have a conversation, not a monologue. This is a conversation, okay?
No, it's not a monologue. I want to save you time in describing all of this complication of people saying this and other people saying that, and that person said that, and that makes no sense, and that person...
This is how science works. It's a conversation between experts.
No, and what people say is irrelevant.
What's happened to Tabistar since then? You tell us. This is your field. Tabistar is no longer considered to be an example of a Dyson sphere or artificial artifact, right?
Yeah, but look, Michael, you pay attention to what people said and what the media said and all. For that, I just want to give you one quote of basketball coaches that say to their team members, keep your eyes on the ball, not on the audience.
I'm
you are keeping your eyes on the audience and saying, oh, this person in the audience said that. That person, the media paid attention to this and said that, and therefore,
Avi, I'm asking you.
What are the aliens?
I don't care
about that.
I'm asking you what you think as a professional of Tabistar.
No, I think of Tabistar, there wasn't enough evidence at the beginning. Nothing conclusive should have been said. And right now, the people that discuss the subject scientifically admit that based on the wavelength dependence, based on some other properties, it may be objects that are circling that star and blocking our view. Okay, so, many times in science, one thing you have to understand, the evidence is not sufficient to rule out or rule in a particular interpretation. That's part of the scientific process. We should not pretend that scientists must keep everything in closed doors and only come out when they are sure, because that is unnatural. The king, the emperor, has no claws. Basically, science is a continuous process of gathering evidence, and most of the time there is not enough evidence to conclusively decide one way or the other.
Yeah.
But what the crime that is being made right now with respect to Oumuamua, there wasn't enough evidence collected because people thought it must be a rock, and therefore now people say it's definitely a rock. Because that's what we thought originally, because there is not enough evidence to think that it's something different than a rock. And what I'm telling you is, this is self-fulfilling prophecy. When you don't put money into a search, when you're not expecting the unexpected, you will never find it, because it's like putting blinders on your eyes.
Of course,
saying, I know the answer in advance.
Yeah, but
yes. My point is simple. Yeah.
How did we come to the conclusion that Tabistar is not evidence of extraterrestrial civilization? The way we did that was further research. So I agree with your point there. But this is my point. Anomalies like this tend to work themselves out in the long run. Before you say something is out of this world or extraordinary or intelligently designed, first let's look for the natural explanation. So what you're talking about here is signal detection theory. Yeah.
We started the discussion by me explaining that people that try to attend to the anomalies of Oumuamua came with explanation of something that we have never seen before, even if they try to contemplate a natural origin. And my point is, each and every case that I mentioned in which a natural origin was associated with Oumuamua had difficulties. Okay, and I mentioned specifically the difficulties, and I mentioned that none of them is something that we have seen before. Therefore, we should not rule out the possibility that it's artificial. And therefore, it should be considered as a viable option that we should entertain by gathering more evidence on similar objects. So I'm just following the scientific process, which says you have a number of possibilities. You should not rule out an artificial origin because the other possibilities appear less likely, at least to me. If you want to believe in a hydrogen iceberg, unless you propose something else, if you come up with another model, great. But I mentioned to you the models that were put in the scientific literature, and these are the models that I mentioned and criticized. And I have a problem with each and every of these explanations. Now, if you want to claim that a cloud of dust 100 times less dense than air that we have never seen before, or a hydrogen iceberg that we have never seen before that should evaporate along its path is more likely than my interpretation, go for it. We haven't seen it. You can go for it, and we will collect more evidence, and see if it's a hydrogen iceberg or see if it's a cloud of dust. Okay? But these possibilities should be put on the table, and we should collect more evidence. That's all I'm saying. However, those that say, like you, we need extraordinary evidence to even contemplate the possibility of an artificial origin, would say,
contemplate.
We don't need to collect any evidence. We know the answer.
Not contemplate, Avi. You've done more than contemplate in your book. I read your book. I loved your book. It was very artfully done and argued. But at some point, you make the step across the line over into, I think this is good evidence of extraterrestrial intelligence.
Well, I explained why.
I understand you explain why. And most of your colleagues disagree with you. So this tells us this is not settled science. You cannot say we have made contact with extraterrestrials when none of your colleagues agree with you.
I did not say that.
You implied it very. If you read the book, I read the book. You imply it very strongly. The reason your book is one of the best-selling books in America today is not because you have an anomalous rock you think is interesting and we should do more research. You've stepped over the line into, I've made a commitment that I think this is a good sign of extraterrestrial intelligence. That's why people are so fascinated by this, right?
No, because what I said is the other alternative interpretation that we have. Usually you have several interpretations of the evidence, okay? And I look at the others, which are a hydrogen iceberg, a cloud of dust, or a fragment of a disrupted object. These three possibilities. I'm not talking about the bloggers that would just say things without any substantiation.
I'm not talking about the bloggers. I'm talking about your colleagues. I'm talking about the
scientists that wrote papers. And I ask you to select between the four options. You have a hydrogen iceberg, you have a cloud of dust, 100 times less dense than air, you have a fragment of an object that was tidally disrupted by passing close to a star, okay? And you have an artificial origin. You can select whatever you want. To me, it sounds like the artificial origin is more likely. Now, the way to prove one way or another is to take more evidence. But I would argue that given those possibilities, the artificial origin is the most likely. You can decide differently, but I'm putting it on the table. What the people that argue against me say is the artificial option should be taken out until we rule out that it's a hydrogen iceberg and provide extraordinary evidence or bring an alien to shake their hand. And only then, they would consider that fourth possibility. And I tell you that if you're never looking for extraordinary things, you will never discover them. If you're never funding them at a level of 0.1% of the search for dark matter, if you are discouraging young people by having this acidic intellectual environment that forbids discussion on this subject, then you will never find them. Why? Because you're not checking.
Yeah.
It's not because that doesn't exist. Yeah. Reality doesn't care about us. We can argue forever. Reality exists even if we ignore it. And what do we accomplish? Look, think about it. What do we accomplish? That we remain ignorant and keep arguing about it. I don't care about Tycho Brahe's mistakes. I don't care about some people saying something about...
You're the one that brought up Galileo, and you compare yourself to Galileo. You're not seriously saying that your own colleagues are refusing to look through the telescope, because they've looked through the telescope. They know what you know.
No, what they're refusing... No, I use the telescope data. What they're refusing is to fund the telescope, to fund the research that will check whether there are technological signals. They're not willing to discuss funding to search for something that we haven't seen yet, okay? And whereas in the context of dark matter, hundreds of millions of dollars were already spent on searching for something that we have not seen yet.
Let's return to that.
Ask yourself, why is that part
I
of the
agree. I agree with you on that. Okay. But they're not just saying, let's look and try to figure out what dark matter is. It would be the equivalent of them publishing a book saying, we have figured out what dark matter is. This is what it is. When the vast community of people that study dark matter say, no, that we don't agree that's what it is. That's what you think it is.
Well, based on
we disagree.
Look, Michael, it's not philosophical.
It is philosophical. It's epistemological. When you're dealing with anomalies, and there's no consensus.
Let me finish my point. Anyone can say anything. The question is whether it's substantiated. So a person can say, there is no evidence for any anomaly. Okay, he can say that. But then when someone else that is a more serious scientist says there is an anomaly that was observed and I want to explain it, and that person comes up with a scenario that is completely far-fetched. Okay, just as an example, then that person is the serious person, not the one that says, oh, there is no anomaly. You can quote that other person that says, no, there is nothing unusual about this rock. You can quote it. But when you look at the anomalies and someone, serious scientists try to explain them
Avi,
using a natural origin,
your colleagues
they came
are,
up with
your colleagues, no, I have to correct you. Your colleagues are not saying there's nothing anomalous about this. They all agree. It's weird. It's anomalous. What do you do with something weird like that?
Yeah.
So I found several papers on this saying Oumuamua is this, it's that. You probably know these, Daryl Seligman and Gregory Laughlin, and, they have an alternative explanation. Here's another one by...
Well, that's the one I mentioned, the hydrogen iceberg. I mentioned that multiple times during our conversation, the hydrogen iceberg,
so I have three
which is
here.
less likely because I wrote a paper after the paper that you just cited that demonstrated that such an object would evaporate along its journey. And that paper is Tim Huang and Abraham Loeb. You can find it in the literature. This is science. Someone proposes something, then you examine it.
Right.
And you decide if that scenario makes sense. And it's all based on scientific reasoning, rather than someone on Twitter putting a single line saying, I don't believe it.
I understand your frustration, Avi, but I'm trying to bring this above the Twitter level. Okay, here's another analogy. I'm a big supporter of the SETI program, and I wish they still had government funding, and they have private funding, and to me, it's totally legitimate what they're doing. And they're saying we should keep searching.
Explain the fact. Sorry, before we continue, how do you explain the fact that the mainstream of astronomy is not funding this research?
I don't know, because this is not my field. All right. I have no idea who competes for what funding and how that's decided. I just know that, in 93, the government cut off funding.
Wait. Let's not move from that. What do you mean you don't know? You know the questions that are being addressed by SETI. The question is, are we alone? Is there a technological civilization out there? That's the question. If you ask the public, why is my book listed on the first week of its appearance as number 7 on the New York Times bestseller list? It's because the public is being starved by the scientific community that is refusing to fund or discuss this subject. Now you tell me, I don't know why SETI is not funded. I have no clue. I don't work in this field. Of course you know. You know that this subject is being ridiculed. And this subject is ridiculed for the wrong reason. Because people are saying, on the one hand, you have science fiction literature. We don't trust that literature. Then you have UFO reports. We don't trust those reports. Therefore, we will never degrade the scientific studies that we do to the level of the public. Now, to that I say, if you go back to the Dark Ages, you would find discussions about the human body having magical powers, about the human soul being in the body. Therefore, there shouldn't be any operation of the human body, no dissection of the human body. And imagine if the science community would say, there are all these ridiculous claims about the human body. Therefore, we will never address the human body. Think about modern medicine. Where would we be? My point is, science has a commitment to address questions of interest to the public that can be addressed with a scientific method. Yeah. And it's just inappropriate for the mainstream of the scientific community not to fund SETI at all. It's inappropriate. You can't say, I don't know, I'm not working. You know very well, just like the public knows, this is a question of interest to everyone, and the public funds science. And the scientists shy away from discussing it because they say, there are all these UFO. How can that justify ignoring this question?
Yeah. So here's my analogy. Let's say Jill Tarter and Seth Shostak at SETI come out with a paper and then a book in which they say, well, we've been searching for signals and we found an anomalous one. It's not exactly the equivalent of a sequence of prime numbers like in Contact, but it's something like that. And no other stellar system that we know of, rotating black holes or neutron stars or quasars or anything, gives off a signal like this signal we found here. Now, what is it? Okay, what is it? Now, let's say they come out and go, well, we think it's evidence of extraterrestrial intelligence. We have made first contact. Wouldn't you as a scientist say, wait a minute, mate, you have not made that conclusion. You found an anomaly, but that's different than finding a signal that you then say, we've detected a hit, like the wow signal that was famous back then.
What I would say, let me tell you what I would do. I would try to think immediately about alternative explanations. Okay, that's what I would do. And if I find something that looks more plausible, for example, a spinning neutron star as an explanation for a pulsar, which initially was dubbed the little green man, okay? If I find that the concept of a neutron star is a solid one, a viable one, and a spinning neutron star makes sense, and you can get a pulsar out of that, and therefore it's not extraterrestrial intelligence, I would write a paper about it and advocate for that. That's all. And that's part of the scientific process. I should tell you, there are many anomalies in physics, and that's the way they are approached. Different people come up with different interpretations. That's why I mentioned to you the 3 other interpretations that were proposed after the publication of my paper as a way of alleviating the issue of an artificial origin by proposing a natural origin. To me, those interpretations are yet not more appealing. Now, if Jill Tarter comes up with the alien interpretation, and I come up with something that sounds just like a spinning pulsar, a spinning neutron star is the origin of pulsars, I would believe my interpretation better because that is a natural origin and it's as viable or more for explaining pulsar. So it's all a competition, it's let the fittest models survive. And by providing more data, eventually you cull out the possibilities that do not make sense. And I don't see any problem with Jill Tarter coming up with this suggestion. That's completely legitimate as long as I can think about it and come up with natural suggestions. And if those make more sense, I would abandon hers. Everything is on the table. Everything is allowed. There is no taboo. The point is, once you put a taboo, you are losing sight of possibilities. And I should say that some of my main critics, I regard them as that congressman, that years back used to make anti-gay statements. And if, in March 2020, after he finished his term, confessed that he's gay. So some of these people that are very fierce contrarians, I would not be surprised if deep down they're intrigued by this possibility.
Yeah, I'm sure they are. How could you not be intrigued by this? It's one of the most interesting questions in all of science. Are we alone? Right. I mean, the Fermi paradox, the whole thing. Everybody knows this. It's a great problem. And as far as I've concerned, if I was science czar, I would give a ton of money to SETI and you and turn the telescopes on all these objects. But
how do we change the culture? How do we change the culture?
I think it's been changing ever since Sagan. I think he's made it far more legitimate.
Oh, come on! You're talking about a minute change, being changed. Okay, so now we're getting 400,000 from NASA instead of 100,000 2 decades ago. Really a big change. I'm talking about a factor of 1,000, not a factor of 2 over several decades. Okay. A factor of 1,000 now. Right now.
Yeah. So here's the question. In terms of this is sort of a signal detection problem. That is, at what point can you say that we know enough about the detritus of interstellar space and what objects are out there that could come hurtling into our solar system that we know that if it doesn't meet these criteria, it's extraterrestrial intelligence? At what point how confident are you that you know enough about what's out there that we can rule all that out?
Oh, it's very simple. I'm just, this is something that a kid, a 10-year-old kid can understand. You take a camera, snap a photograph, up close, and you can tell if it's a rock or something else. That's all. And I'm suggesting deploying cameras within the orbit of the Earth around the sun, such that incoming interstellar objects, at every given time, there are many of them within the solar system, numerous, maybe 10 to the power 15, given the statistics about Oumuamua. 10 to, quadrillion objects within the solar system right now.
Yeah.
And every few years, another one passes just like Oumuamua close to us so we can see it. But if you deploy cameras, you would see many more.
Yeah.
And it offers the advantage that one of the cameras would be close to the path of one of them. Now you would tell me, okay, but maybe most of them are rocks. I say, fine, but it's worth the investment, because if 1 out of 10 is not a rock, it would revolutionize our view about our place in the universe.
It's not a rock.
So I'm advocating for a very simple method of telling the difference that is not at all under dispute. You take a picture, and a picture is worth 1,000 words. I wouldn't need to write this book. It's many thousands of words, 60-something thousand. I would save those 60,000 words. Instead of my book, I would replace it with a photograph.
Single picture.
That's it.
But what if the picture is not clear? You can't quite make it out. Maybe it's this, maybe it's that. Maybe it's a rock, maybe it's a solar sail. I can't quite see. That's what I'm asking.
When I say picture, I mean a clear, crisp, clear picture.
Yeah. You mean that was the equivalent of a solar sail, like what we made? Like the Planetary Society solar sail, something like that.
I don't have a prejudice, but I'm saying I can tell the difference between a rock and something else.
But what if you can't? What if it's in between that? What if it's a kind of a reflection? You can't quite make it out. It's a little blurry.
Then let's argue about it and maybe land on it. Okay, maybe land on it and examine it more up close. Now, the other thing I should say
is that
you have meteors.
Sorry.
There are meteors, that are intercepted by the Earth. Yeah. And the meteors, in principle, we can put our hands on whatever is left when they land on the ground.
Yeah.
So if we find interstellar meteors, some of them might be artificial, and then we can examine them. That was never investigated as a line of research. We can also use the moon as a museum, because the moon doesn't have any geological activity, doesn't have an atmosphere that burns up everything that enters, that is smaller than the size of a person. And so the moon collects everything, and we can use it as an archaeological site. When we establish a sustainable base on the moon, we can search the surface. It's just like a museum for objects that do not look like rocks, that were collected over billions of years of the moon's life. And so I'm suggesting multiple things. First, searching for interstellar objects passing through for the first time. Second, searching the moon or the Earth for those that collide with those. And the last thing I would say, there are objects that are trapped because they pass close enough to Jupiter, and Jupiter deflects them. And as a result, they get trapped in the solar system. So the Jupiter-Sun system acts as a fishing net that collects interstellar objects. Yeah. And on every topic that I just mentioned now, I wrote multiple papers. I have, over several dozen of papers related to the interstellar object, which is a new frontier as far as I can tell. So I'm addressing this subject just like I address any other subject that I worked on. In cosmology, in black holes, I say something unusual happened. We found this object. We don't know for sure what it is, but it's weird enough for us to invest funds to get more data, more evidence. And that's, I think, the biggest message we get from Oumuamua, that we should pay attention to these, because they might be plastic bottles.
Well, you have that billionaire friend of yours in Russia named Yuri. Maybe he'll put the money up if the federal government won't.
I haven't discussed it with him. And by the way, that's not a substitute. The point is, you need to change the culture. And that's my complaint.
Well, okay, but
the culture.
Yeah. Not just the culture of interest, though. You want somebody to take a checkbook out and write a check. And so that, to a certain extent, you have to convince your colleagues to vote for those sorts of things.
Exactly.
Yeah.
Exactly. Well, so I wrote the book, and I write scientific. Exactly. I wrote scientific papers, and I wrote the book with that in mind, to change the view of my colleagues. Yeah. Now, it may not work at first because it sounds like it will be a shock to the system. But that is my long-term objective.
Okay,
that is my long-term objective.
I understand, and it's a good long-term objective. A lot of scientists have that. You've gone beyond that. In my opinion, your book makes a strong argument for detecting extraterrestrial intelligence in this blurry signal that we can't quite make out what it is. It doesn't fit anything we know. You've made that jump. You mentioned the Allen Hills Mars rock. From, I think that was 96 during Clinton's administration. And the initial papers on that were, we think we've detected life from Mars. And there was a huge press coverage of this. Clinton himself gave a speech about it and why, funding for NASA should continue, because this is the kind of exciting thing we're doing. But then it took a few years for the colleagues who study paleontology and rocks and geology and whatnot to kind of grind through that and say, you know what? No, the signal is just not strong enough to go from a natural explanation to, it'd still be natural, but from just a chemical to an organic, right?
So what are you arguing? That you walked on the beach, you saw mostly rocks, and therefore there shouldn't be any plastic bottle on the beach because you saw only rocks in the past. Is that what your argument is about?
The claim for somebody to say, we found life on Mars, that's an extraordinary claim. How extraordinary is the evidence from that asteroid and from the Allen Hills discovery? Not very extraordinary. That's the problem. That's why you need extraordinary evidence.
No, that's not what you need extra. That's why you need more evidence. And the evidence is collected after you recognize this as a mainstream activity. The evidence will not be collected if you make arguments that always you need extraordinary evidence at the same. So it's just like saying, and I said that already, like stepping on the grass and saying, look, the grass doesn't grow. You are saying, I need extraordinary evidence, but I will not give you funds, and I will discourage young people from collecting any evidence. And how can you get extraordinary evidence if you are not allowing it?
Okay, that's a fair argument, but again, back to the Allen Hills thing. So, I'm not arguing that. I'm asking you, again, back to signal detection theory. At some point, you say randomness, signal. Right. So not to relate this to you, but the intelligent design creationists, they say, look at the face on Mars. Okay. The UFO people go crazy over the face on Mars. It's not a face. It's not monumental architecture made by Martians. It's an eroded mountain that in our mind's eye, we see a face because it's degraded data. And when you take a close-up picture, you see it's an eroded mountain. Now the intelligent design people say, but if you look at Mount Rushmore, that's intelligently designed. There's no way you could argue that was the result of erosion, right? So this is the question. Okay. Where do you go from a naturally occurring thing to something that's intelligently done? It has to be really clear.
Okay. Yes, and I say that it was, in the case of Oumuamua, I pointed out there were a number of anomalies. Each of them may be likely at 1%. You multiply 6 times 1%, you get 1 in a trillion likelihood. When you have 1 in a trillion likelihood, I would argue that's sufficiently extraordinary to entertain the possibility that it's not something you know, okay? And those anomalies were detailed in my book. I speak about the evidence. That's what guides me. I did not have an agenda to start with. I worked in other fields. I was, in 2007, I wrote a paper about using radio observatories that were designed for cosmology in order to eavesdrop for radio signals coming from other civilizations. And I remember just a month after the paper appeared, Jill Tarter came to Harvard and gave a colloquium, and she said, even Avi Loeb is entertaining the possibility of other civilizations and discussing it in a scientific paper. So she said that to emphasize the fact that a reputable cosmologist is working on SETI, which was my first paper. And this is just to alert you to the fact that I didn't come with any agenda. And if this object would not appear, I would not be even discussing it, SETI as my focus in research. And so I was guided by the evidence. I see the evidence. I will never back down based on what people say on Twitter or people say around me. I will back down if the evidence against what I argue is clear, or if there is a plausible alternative which involves a natural
order. There you go. You said it. I will not back down. Back down from what?
From my points, the ones that I explained.
Which is that this is a signal of extraterrestrial intelligence. That's your position.
That's the possibility that it's out.
Not just the possibility. Not just the possibility. You have stepped over the line.
Let me state clearly what my message is. That the possible interpretation of this object as an artificial or object rather than a natural one is more likely in my mind, given the explanations that were given for a natural origin.
Okay.
And if someone would come with a better explanation for natural origin that looks very compelling, I will accept that.
Let's think about all the things we've learned about the solar system just in the last, say, quarter century. Like moons. We thought we understood moons. Moons are like this. And now, like every moon we look at, it has some weird feature. And every press release you ever read about these, like, oh my God, I had no idea moons could do this, moons could do that. How confident are you really that we really know so much about interstellar debris we can rule out that it couldn't be something else that's natural?
No, I'm not confident at all, and that's why I advocate for searching for more objects of the same type that share these anomalies of Oumuamua, and then getting as much evidence as possible about them, rather than saying it's never aliens, it's always rocks. Forget about it.
Yeah, I agree with you. I agree
ridicule anyone that proposes that. No. That's the other thing. Why not put it on the table? What's the problem of putting it on the table?
Nothing.
Explain
to
me why that should be.
You did put it on the table, and you're the head of Harvard Astronomy. So you can't be canceled for this. You can't be fired for this, right? You are legitimizing it. Okay, that's not my point. My point is that to do those kind of number crunching you do, like 1 in a trillion, 1 in a billion, whatever. So it's probably an extraterrestrial signal. Do we know enough about what we know? That is, there are known unknowns. That is, there's things we just know that we don't know.
This was the first object we found from interstellar space. And of course, we don't know a lot. And by the way, I wrote a decade earlier, I wrote a paper forecasting, the first paper in the scientific literature, forecasting how many interstellar objects we should expect and whether pan-stars will see any object, of the size of Oumuamua. The prediction was off by a factor of 100 to 100 million, taking all the uncertainties we have about the solar system and assuming that other planetary systems around other stars are similar to the solar system. We calculated the inventory of interstellar rocks and found that pan-stars should see nothing. The fact that let's imagine Oumuamua is a rock. The fact that it found this rock implies that the number of rocks was underestimated by a conservative calculation by a factor of 100 to 100 million. And my collaborator, Amaya Moro-Martin from the Space Telescope Science Institute, reanalyzed what we did in 2008 and did it again after Oumuamua was discovered and reached exactly the same conclusion. She says that it's very difficult to explain a population of rocks at the abundance needed to explain the detection of Oumuamua if you were to adapt what we know about the solar system and other planetary systems.
Yeah. I know you don't want to talk about Galileo, but you've probably seen this figure from his work where he has embedded in the text the actual pictures of what he saw of Saturn looking through his telescope. And he said, I have observed it is 3 objects. This was his conclusion. So there's 2 reasons for this. 1, degraded data. The data wasn't very good coming through his little telescope. And 2, there was no theory of planetary rings. No one had even conceived of planetary rings. So in his mind's eye, filling that in, what could that be? That has to be like 2 moons or it's 3 stars rotating around each other. And so this is what I worry about. Oumuamua might be something like rings that we can't even conceive of. So through that fuzzy graded data, you see where I'm going with this.
Look, you will not find someone that agrees with you more that science is work in progress, that is done by iterations, and that very often we are wrong, we're mistaken. If we work on the frontiers, at the cutting edge, if on the other hand you want to promote your image so that you get honors and awards, you would not put any skin in the game. You would never make a prediction that can be falsified, which is pretty much what is done by the mathematical physics community right now, and what is done by people that keeps repeating what we already know and saying that the future will be the same as the past. They don't put any skin in the game. I completely agree with you. In the last decade of Einstein's career, when he was the most experienced throughout his career, he made 3 major mistakes. He argued that black holes don't exist. He argued gravitational waves don't exist, and that spooky action at a distance does not occur in quantum mechanics. He was wrong on all 3 based on later experiments. And, making mistakes you don't need to give me the example of Galileo. Obviously, every great physicist in the history of science made major blunders, major mistakes. Because when you work at the frontier, you don't know which path to take, and sometimes you go in the wrong direction. And I admit, I may be completely wrong, but I say that traditionally, and that's the way it should be done, physics is based on evidence, not a monologue where we mathematically, do all kinds of gymnastics and say, oh, there should be extra dimensions, there should be a multiverse, and everyone says, yeah, we are smart, let's give each other. And that's not the way physics is done. It's not about us, it's about nature. Yeah. And we should be humble and modest. Okay, so we don't know until we collect evidence. All I'm advocating is that Oumuamua is a good trigger for our attention to collect more data on interstellar objects, and that interstellar objects are a new frontier that was not imagined by the SETI community in the past, because the SETI community in the past focused on electromagnetic signal. I'm saying, look, there is a completely different approach based on objects, and it is more promising. Why? Because civilizations that are dead, which are not transmitting radio signals, may have already sent out trash into space, and we can find that trash.
Yeah. I think it's a great idea to keep looking for that. The reason I brought up the Galileo error was not just to say scientists make errors. It's the kind of error he made because of those two reasons. The reasons you're faced with. Degraded data, you can't quite make out what's going on there, and nothing that can account for it from what we know. But as it turns out, planets have rings. Okay, we didn't know that. Now we know. And so all I'm saying
that's
is,
a good point.
Before we go the extraterrestrial intelligence conclusion, which I realize you're not haven't made that completely, but still, it's strongly implied in your book. Before we say that, we should first make sure we don't have more knowledge about what these other objects could be like. We can't rule out what we don't know, I think, obviously.
Michael, we both agree that that we know better. We gain knowledge by collecting evidence. We both agree on that.
Yeah.
And my book is a call for action for getting more evidence.
Okay? Good. I'm on board with that.
I'm willing to be proven wrong, but my basic point is if you step on the grass, it will never grow. If you ridicule this possibility, it will never be considered because young people will worry about their jobs security. Old people will prefer to be in their comfort zone where they take no risks. Progress in science is done by people that dare to make mistakes. I dare to make a mistake. You are calling out this issue that I may be wrong, and I completely agree with you. But I'm saying that in order to push science forward, you have to be willing to make mistakes. If you don't entertain possibilities that may be wrong, you will not make discoveries. In the commercial sector, risk-taking is an inherent part of companies like Google. Why would it be forbidden in a scientific sector? When you get tenure, why wouldn't you entertain possibilities that stretch, that push the boundary a little farther and check if they are right or wrong based on collecting new evidence? My point is, it's not just ridiculing the possibility that I bring up. It's ridiculing the entire search. That's what is happening right now in the scientific community, and that's what should be changed. And that's the call for action in my book.
Okay, fair enough. Again, if I was the science czar, I'd give you guys 10 million a year, 100 million. I don't know, whatever you need, because I think it's a fascinating subject. It's one of the most interesting. The other part about your book, I like the memoir part. I enjoyed that very much, and you do make an analogy there in terms of the odds of meeting your wife and how well that worked out. And, what are the chances of my meeting her again and so on. And that's kind of an analogy for what you're talking about with Oumuamua, right? I was just wondering, do you know this? Yeah, sorry, go ahead.
Go ahead.
I was going to say, do you know the singer-songwriter Tim Minchin? He's Australian. He's a real big pro-science guy, so his songs are all related to reason and science and so on. Anyway, he's got a song called If I Hadn't Met You, and it's a love song to his wife. And if I hadn't met you, this wonderful thing wouldn't happen, and this wouldn't have happened. I wouldn't have somebody rub my feet and blah, blah, blah. And then it shifts in mid-song. Of course, he says, I would have met someone else. Maybe she was taller than you, but not as good looking. Maybe she was more athletic, but not as creative as you. And whatever happened, I would think that's 1,000,000 to 1 odd, billion to 1 odds I would have met you. Okay.
Well, Michael, the second option is much less romantic.
Yes, I know.
That's why you never say that.
I understand. Don't sing that song to your wife.
So, but my point is, really, aside from what we discussed until now, my biggest message that I hope people will internalize, but I'm not sure they will actually, and it's a message of modesty. That's the biggest message I got from astronomy. Not only because the universe is large and we're small, also we live a short time. And it really struck me when both my parents died a few years ago that, why pretend, why portray an image that is not necessarily accurate? Let's just be straightforward and focus on the ball, focus on the substance. I'm not, what you see is what you get when you discuss things with me. And everyone that knows me knows that. And I've been the longest serving department chair in the astronomy department, even though I took an approach which is straightforward and transparent. It turns out that it saves a lot of energy and time because people trust you. When you say what you think, they can disagree with you. I can be wrong. People can disagree with me, but they know what I think. And they know that what I say is what I know, okay? So it could be that what I know is misleading me, or I misinterpret that. But what I'm claiming is, in the frontiers of science, it always is the case that you are sometimes vulnerable, as you mentioned. Galileo was vulnerable to data that is incomplete or to imagining things that are not real. But I argue this is much better than imagining things that cannot be even tested, like the multiverse or extra dimensions, because to me that is like hallucinating. You can think that you are wealthier than Elon Musk and be very happy at that thought. This is a happy thought. The thought of Aristotle that we are at the center of the universe was a happy thought. It was sophisticated, all these fears, but nature may be simple. And Aristotle's view was wrong. We know it's wrong. So who cares how sophisticated and beautiful and how happy this thought is that we are at the center? Who cares how much money you think you have? Just go to the bank and check how much money you have, and then you design your actions accordingly. That's my point. We should be sober, not high on drugs, okay? We should be sober. And the way to be sober, is to get a reality check. And the reality check comes from experiments. And if you have ideas that cannot be tested, okay, they should be on the sidelines of physics. And ideas that can be tested, like, are all the objects that resemble Oumuamua in terms of their peculiar properties, are they artificial or natural? That idea can be tested by searching for more and then examining them, taking a close-up photo and so forth. Such an approach should be encouraged, blessed. We say, oh, look, if we find something artificial, it will have such huge implications. Let's go and search. People should be excited about it. Instead, what they're saying is, I wish it never existed. It's never alien.
Okay. Let's say
extraordinary evidence.
Here's another analogy that I thought of reading your book, because you mentioned the multiverse. Let's say my friend Kip Thorne, who's a longtime supporter of skeptics at Caltech, got the Nobel Prize for gravitational waves. Let's say he publishes a paper next year, and then 2 years later he has a best-selling book out in which he says, we've detected these gravitational wave anomalies that could be evidence of another universe. Our brain universe collided with the other universe's brain and caused these ripples. And this is evidence. But if he said, I have found the multiverse, or if he said something along the lines,
first to buy this book. I will buy let me tell you my reaction. I would buy this book. I would read it carefully, or if he has scientific papers on the subject, I would read it with great interest, because that's the thrill of doing science, that there is an opportunity to find something completely new. I would read it with great interest, and then the immediate reaction that I will have, okay, that's the interpretation he gave. Can I find alternative interpretations, much more mundane, that would explain the same phenomena that he's reporting? That will be my immediate response. It will not be to say, you are not allowed until you bring me extraordinary evidence. You're not allowed to discuss it in a book. You're not allowed to discuss it in public until you bring me. I would never say that to Kip Thorne. I would say,
but would you
great
not...
book, I enjoyed reading it, but I found some alternative interpretation.
Right.
And then I will write a paper about the alternative interpretation. What's the big deal? It's part of the scientific process. I see no harm done, because we should admit that the emperor is naked, that most of the time in the scientific process, most of the time we have uncertainties because the evidence is not clear enough. So we put out the possibilities on the table. So if someone says, I think this possibility is more likely than others, okay, that's your opinion, but I'm intrigued by that, and therefore I search for alternative interpretations of the same evidence. And also I encourage other people to do experiments that will collect more evidence and distinguish between the interpretations. That is the natural process of science. There is nothing unusual about it, but people have a problem. They have a problem with the subject of other kids on the block being smarter than we are. I think it's very unique to this area that having other kids on the block that are smarter than us is something that drives people crazy. And I don't understand why it cannot be dealt with in the standard scientific approach.
Yeah. The reason I brought up your relationship with your wife and the statistical odds of meeting that particular person, because it reminded me of a line that Dick Feynman used about, today in my drive, I saw this license plate X29337L. What are the chances of that? Well, you could crunch it out. It's like 567,000 to 1. Until you look at it, then it's 1. Probability is 1 because that's the one you found, right? And so we deal with a lot of these statistical laws of large numbers because people think coincidences are more than coincidences. They think there's a signal there in the noise. But, example I use is the actor Anthony Hopkins tells this story about where he got hired to play in the role of this film called The Girl from Petrovka. Anyway, he didn't know anything about the story, so he goes to his London bookseller. They don't have a copy of the book. So he's heading down to home. He goes to the tube station. There's a bench. There's a book on the bench. No one's there. He picks it up. It's The Girl from Petrovka. Okay, that's freaky enough, okay? That's freaky enough. 6 months later, he's telling this story to the producer who says, I lost my copy of that book. And they flip through, and there's his handwriting in the book copy that Anthony Hopkins had, right? That is freaky. That is totally freaky.
I agree with you.
But, the statisticians who told me about this, they make the point, well, there's 7.5 billion people. There's, 500 million books. Those are the ones that stand out. How come he didn't find a copy of The Silence of the Lambs or, one of his other films? So there's a survivor bias. We notice the things that stand out.
No, I agree with you. But when you see the first object coming from interstellar space and it looks weird, that's what bothers me more than just seeing 100 and one of 100.
Okay.
Seeing the first one. But I agree with you. I mean, there may well be, a natural explanation, and I may be wrong. I'm completely happy with that. I'm not happy with the lack of respect that some people have for entertaining this possibility, because I think that is a negative force in science. When you have heard groupthink, dominating the scene. Let me mention an example. In the 1930s, there was a book arguing that Einstein's theory of relativity is wrong, and there were 30 physicists signed on it.
No, 100.
And then Einstein was asked.
It was titled 100 Scientists Against Einstein. Yeah.
Okay, 100. Sorry. So Einstein was asked, what does he think about it? And he said, well, if there was a strong argument, then one person could have made it.
Right.
Why do you need so many?
Right.
So my point is, people come together very often because it gives them a bigger authority. They think that the truth is dictated by authority. It reminds me of what a philosopher said at the end of an annual conference at the Black Hole Initiative, for which I serve as the founding director. This philosopher said, if the physicists, a community of physicists, agrees on something for a decade, then it must be right, because physics is what physicists do.
Yeah.
Now, I raised my hand. I said, how? can you say something like that? Has nothing to do with consensus. It's not about the number of likes you get on Twitter. It's not about the number of people agreeing on something. It's about evidence. And if the idea has no evidence in its support, then it may be wrong. And that's a fundamental shift in the culture of physics.
Here, the consensus science, it's not a democracy. It's not likes on Facebook. Just take the 97% figure for climate scientists who agree that anthropogenic global warming is real.
No, but that's based on evidence.
Yeah, that's based on evidence. That's right. But the public doesn't know the evidence because we're not climate scientists. I can't read the papers. They're technical, right? So I depend on the scientific consensus to tell me either there is a consensus, yes, or it's divided, half say yes, half say no, in which case I'm going to go, well, let's not do anything until we have more evidence. And so the consensus does matter when it's based on experts competing with each other over the same data about what it represents.
Yeah, but look at continental drift. There are examples in the history of science where the consensus view was completely off.
Yeah, but that took, but there they had to have a mechanism. There was no mechanism. What could drive continents to drift? Well, they didn't know about all the plate tectonics underneath, the cells driving the continents, that and more lines of evidence, the magnetic mapping of the ocean floors. That's what.
Yeah, but it's the same story as hot Jupiter. It's the same story as hot Jupiters, claiming that, we know Jupiter, therefore, how can Jupiter be so close to the sun? And my point is that many times nature's imagination is greater than ours.
Yeah.
We should admit that. That goes back to my sense of modesty. Our knowledge is an island in an ocean of ignorance. We should recognize our limitation and therefore do not say categorically, this is impossible. Because that limits our ability to innovate. And we should allow innovation should be encouraged in science. So, for example, I advocate for allocating a fraction of all the funds always for risky projects rather than NASA's way of saying, tell me what you will discover in year 1, year 2, and year 3. That's contradictory to the scientific endeavor of finding things you don't expect.
Well, I thought that's what DARPA was for. I thought DARPA was for these, X-Prize kind of crazy projects.
Well, I wouldn't call them crazy. I would call them risk-taking and blue sky. That's the kind of thing that even commercial
Google does that.
Companies, Google and SpaceX. I mean, because even though they're up for profit, that's what they want. They recognize that every now and then you'll discover something unexpected that will compensate for all the mistakes that you've made on other suggestions. And if it's of commercial benefit to entertain risky propositions, I would assume that in academia, which is not geared towards a commercial benefit, it should be even more popular, but it's not.
Yeah, I agree. That's a problem. Okay, another thought. I wrote one of my columns in Scientific American was called Shermer's Last Law, which is any sufficiently advanced extraterrestrial intelligence would be indistinguishable from God. So the chances that whoever made Oumuamua, if someone made it, they're not going to be like 20 years ahead of us technologically or 1,000 years. They'd be like 100,000, 1,000,000 years ahead of us, right? So, so one thing I was thinking of, would they make a space sail like we conceive of a space sail? I mean, surely they would come up with something we can't even conceive of.
Okay, well, on that, I would say, let's imagine a planet having crocodiles on it and a planet having people on it. Surely the people are more advanced.
Yeah.
Right? Which form of life will live longer?
Probably the crocodiles.
Maybe the crocodiles.
Yeah.
Because they do not invent an atomic bomb.
That's right. Yes.
So it's possible that the ones that are not so smart, they stick around. They live their life, enjoy the food, make technologies that are not really very sophisticated, and they last longer.
Yeah.
Those that are really brilliant, they invent all kinds of technology that, boom, kill them.
This is why I hope you're right, because if you're right and it is extraterrestrial, it shows that somebody made it through the great filter and continued on, at least for a while, as far as we know. Okay, another question I wanted to ask, I wanted to get your opinion on. So Richard Dawkins and I have had a little bit of a fun debate about what would the aliens be like? Because I'm always critical of UFO people. Aliens are bipedal primates that speak English with an Indian accent, and they got some gnarly stuff on their forehead. Okay, this isn't what the aliens are going to be like. Okay, we probably can't even imagine what they'd be like. But hang on, but Richard's counter to that, which is a good one, which is convergent evolution. That if you're making your living in the air, you have to have something like wings. If you're in the water, you have to have a fusiform body. If you're on land, you need something like legs and arms. And if you're tool using, well, then you got to have hands. And you're going to have your brains and sensory apparatus on one end and the waste disposal system at the other end. And so maybe it's not completely crazy to think aliens would be something like bipedal primates or dinosaurs or whatever. What do you think?
Not at all. Not at all. Not at all. So I think we will be shocked at the sight of either biological creatures or at the sight of technologies. Just like you said, they would look like magic. And in the context of biological, let me give you an example. The nearest star to us is Proxima Centauri, okay? And that's a dwarf star, 12% of the mass of the sun. It has half the surface temperature of the sun, 3,000 degrees. And it emits mostly infrared light. The sun emits visible light.
Yeah.
And there is a habitable planet that is 20 times closer to Proxima, called Proxima b, than the Earth is from the sun. So it's closer, and therefore it's habitable because it has roughly the same surface temperature. And because it's so close, it has a permanent, most likely it's tidally locked, it has a permanent day side and a permanent night side. My daughters, by the way, say that the sunset strip that separates them is the place where the real estate value will be the highest.
That's right.
But coming back to the creatures, creatures that live on the day side would have to have infrared eyes, okay? And they are used to dark red grass, okay? Now, imagine interstellar travel agencies telling them, let me offer you some desirable destinations for your next vacation. They will never suggest the Earth because the visible light would hurt their eyes, and they're used to dark red grass, not to green grass. So they will never come to visit us. And the only way for us to find out is to go there and entice them actually to come back to our Earth with a water-based drink. But but my point is, think about infrared eyes. Like that must be something really different. And and being on a continuously, steadily lit side. Obviously, if you cross the sunset strip, you get to a completely dark region that is dark forever, and that the forms of life you form there are completely different than the forms of life you form on the. And I would argue that we don't even know if the form of life we have on Earth is most likely, because if you look at recipe books, you start from the same ingredients, and depending on how you mix them and how much heat you add, you can get very different outcomes. And imagine the early Earth that had, a soup of chemicals. We don't know if you mix the soup of chemicals differently than the random process on Earth, what kind of life you get. One way for us to improve our imagination is to produce synthetic life in the laboratory. And that's something that my colleague at Harvard, Jack Szostak, is trying to do. Yeah. He's a Nobel laureate.
Yeah.
And once we produce synthetic life in the lab, we can change the conditions, see how the outcome is, how sensitive it is to the circumstances, and perhaps that will help resolve the argument you had with Dawkins, in the sense that, we can see how different life could be. But it will take a while before we form complex creatures, in the laboratory, that might be a while. However, we could simply go out and search, just like I jog in the morning, I see all kinds of animals that I've never seen before, we can go to the next star system, start to look around, and it's a matter of exploration.
And on that question, ethically, should we be doing that? Should we become a multi-planetary species? Should we send signals out? Your colleague Stephen Hawking famously said, we shouldn't tell anybody we're here, because look what happens when an advanced civilization comes into contact with a less advanced civilization here on Earth. They eat them or enslave them.
Yeah, I definitely agree that when you enter a room full of strangers, it's much more, it's prudent not to speak, but to listen, okay? The problem is we already sent out radio signals over more than a century.
Yeah.
And if there are other civilizations with detectors that are similar to the radio telescopes we have, they already know about our existence within 100 light years. They might respond, but it will take them a century even to send beams of electromagnetic signals back, not to speak about coming back to visit us. But I agree with you that we should probably not speak out. And moreover, we don't know how much more advanced and how to search for them. And the other thing I wanted to mention is in the context of objects that enter the solar system. Obviously, we look for things that move roughly at the same speed as the rocks that we have seen. But if something moves close to the speed of light passing through, the astronomers will just dismiss it, especially if it's small and it doesn't reflect a lot of sunlight. It will never be detected. So there could be, we could be flooded with things that we haven't noticed.
Well, like your project to send these little microchips to the Alpha Centauri system, right? What's the status of that project?
Well, still work in progress. So there are teams working on various aspects of the technology. One of them is the what we call the photon engine, or the producing the laser beam that is very powerful, about 100 gigawatt or so. That's what you need to lift 1 gram of sail close to a fifth of the speed of light over a few minutes. So that's one component. And then, of course, the sail, how to optimize the material and the structure, the shape of the sail. And then the third major challenge, is communication across a distance of 4 light years. The signal would be very faint. And what's the best way to communicate the photograph that we might take of another planet? To me, this project has 2 additional inspirations. One is that potentially you can launch things within the solar system, to targets within the solar system, and get there very quickly. So we could have chased Oumuamua if we had that technology. We can go after Planet 9 once we know where it is, to get a very quick photograph of it. It would take us just a few days to get to Pluto instead of 9.5 years that it took New Horizons. So, and also the spacecraft is not very expensive. It's the cost of a cell phone,
right?
As long as you have the infrastructure. So most of the investment is overall, just getting out of the solar system. It's about time for us to start planning for that. The space is very big.
Well, it's happening. We're about to colonize Mars. I mean, this could happen in our lifetime.
First of all, we have to be careful about using this word because it has
it's a bad word. Yeah, never mind.
And I don't think that we will go there and establish a sustainable base there, because the biggest issue is really the health hazard. If you are not protected by the shield of the magnetic field on Earth, cosmic rays hitting your brain would basically destroy a substantial fraction of the cells in your brain within a year. And that was not solved. So one way is to go to dig into the ground and go into caves. Another one is to build some infrastructure that would protect the people. But it was not yet discussed enough for us to feel safe in sending people to Mars for a long period of time. And I think it's irresponsible of talking about settling on Mars, by 2050, if we haven't solved the health issue, because it's just like sending people to their death, if we're not careful.
Yeah. Let me ask you another question. So let's say we have unmistakable evidence of extraterrestrial intelligence. One of your newly funded telescopes takes a picture. There it is, a space sail. It's not a rock. People like me are not going, I can't quite see what it is. I don't know. It's everybody can see it. The UFO people, they tell me the reason there's no evidence is the government's covering it up. Why is the government covering it up? Because they're afraid that the economy will collapse and Christians will go crazy and lose their mind and think Jesus has to go to every planet and so on. What do you think would happen, culturally, et cetera, if we made that discovery?
Well, first of all, let me explain. I don't think there is any cover-up. Because you can't cover up the sky, okay? Everyone can look at the sun. Everyone can look at any object on the sky. And astronomers would have found something. Or another way to put it, now we have many more cameras looking around, okay? Because people have cell phones. There are cameras on streets, in cities. There are cameras and there are cameras on airplanes and drones, and you have so much more footage now than we had a decade ago or 2 decades ago. And if indeed there were UFOs, then why isn't the rate of discovery increasing, and why aren't the pictures more clear? But nevertheless, I think instead of declassifying documents that used to be in the Pentagon and looking at them and trying to figure out whether eyewitness testimonies make any sense, instead of that, just forget about the past. Let's just use the best instruments we have right now to collect new evidence in the same sites from where the reports came and see if there is anything unusual. It reminds me of the biblical story about Abraham, the same name as mine, which in the Bible, the story goes that he heard the voice of God that told him to sacrifice his only son, Isaac. Now, if Abraham had a cell phone with a voice memo app, he could have pressed the button and recorded the voice of God, and everyone would believe the story. He didn't have that cell phone. Therefore, we have to decide, do we believe the story or not? So if the Pentagon releases those documents, do we believe these eyewitness testimonies or not? My point is, let's forget about it. Let's behave like kids. That's my main message. Let's not worry so much about the past. What do kids do? They say, I don't care what my parents say. I will check it myself. Okay. So if we scientists decide to check it ourselves, we take our current state-of-the-art instrumentation, deploy it in those sites, and check if there is anything unusual.
But when I'm asking, if we did find it unmistakable, do you think it did be cultural disruption, or do you think people would embrace it?
No. Okay. So I was asked about this yesterday by 3 people that interviewed me. And the way they posed it is, you say that you think it will bring people together because, humanity would feel as if the human species, as if it's one team, because there is someone outside, and it will bring. And by the way, this is not my idea. Ronald Reagan suggested that. And that's okay. So in this case, I prefer to be utopian. In other words, I prefer to dream, just like the song of the Beatles. I prefer to dream about a reality in the future that would be better than the reality at present. Okay, and what I see at present is, people trying to feel superior relative to others. That is called racism. It makes no sense whatsoever. If you think about the DNA composition, and if you think about the big picture scheme of the universe, that's ridiculous. You can see nations trying to feel superior relative to each other. Again, ridiculous. You can see wars. You can see all kinds of, and most of our time and money is about conflicts, if you read the news every day. So, I hate that. I want us to work together towards a better future. We are wasting so much resources. Why not be intelligent and just try to see the good side of the other person and work together? Science is I call it an infinite sum game, in difference from what you find in economics, that is a zero-sum game, where if someone gains, the other person loses. In science, if someone brings knowledge to the table, everyone gains. So it's infinite. You can gain knowledge as much as you want, and everyone will benefit. It's an infinite sum game. So the message of science is, let's work together and build a better future. And that message, by the way, was abandoned in the case of COVID, because China did not allow scientists to come in the early days of COVID, collect as much data so that a proper vaccine will be developed. That goes contrary to the message of science of working together to solve a global problem, right? So politics many times comes in the way of science, in separating people, in establishing paradigms that if science violates one of the paradigms, like it's never aliens. That's a paradigm. If science were to violate that, all hell will break loose, and therefore we should forbid this. So there are these things, and they try to block science, to put blinders.
That's no good.
Not allow free communication, and I don't like this. So I advocate for a better future by dreaming that it will exist. Now people say I'm naive, and I'm happy to be naive, because otherwise I will be depressed.
Oh, I love people like you and Sagan and Freeman Dyson and the big thinkers. No, we need that. Absolutely. So the other part, again, I mentioned the memoir part of your book that I really loved, your stories of growing up in Israel and your religious background, or such as it is, Judaism. So I got to thinking with the, sufficiently advanced extraterrestrial intelligence would be indistinguishable from God. Do you believe in God? Or is it possible God is just a super advanced extraterrestrial?
Oh, well, that's an interesting possibility, and I considered it in some of my Scientific American articles. So let me explain one specific example. We have in cosmology the Big Bang. That's when everything that we see now in the universe started. Yeah. And that's a point where Einstein's theory breaks down, a point in time. If you extrapolate back in time, the expansion of the universe, you get to a point where the density was infinite, or curvature of space and time. And the point is, we don't know what happened before that, because Einstein's theory breaks down and we don't have a unified theory of quantum mechanics and gravity. Presumably, quantum mechanics will cure the singularity of the Big Bang and we would be able to extrapolate back. But there is another interesting possibility, and that is, once we understand quantum gravity, we will figure out how to make a universe in the laboratory by irritating the vacuum, by focusing enough energy in a small volume. We would make a baby universe. Now think about it. That baby universe might lead to another civilization inside of it that will make another baby universe. Just like I have kids that make kids that make kids. So it's baby universes all the way. And that could explain, why the Big Bang started, because it has an umbilical cord that leads to a laboratory of another civilization. So in that sense, the answer may be yes to your question. If we were created. Now, it's also possible that life on Earth was planted by a laboratory.
Panspermia.
But then you need to explain where that... directed panspermia. But then you need to explain how that civilization
got started,
came to exist. And it doesn't really solve the origin of life. What I'm suggesting is a sequence of events that explain the origin of the Big Bang and therefore also life.
Right, yeah. Yeah,
but to answer your question about God, you answered me a more theological question. And by the way, even though some physicists don't put any skin in the game, some theologians did put skin in the game, because, for example, Giordano Bruno, was burned at the stake.
But not because of his many worlds. Not because of his many worlds. I have to correct you on that. That was just one of a long list of his offenses. He disavowed the Trinity, right? He didn't accept Jesus as, the Savior and the resurrection and all that, the virgin birth. He was skeptical of all that. That's what really got him in trouble. The many worlds was just one of the things he got in trouble for.
Right, but in principle, that argument against the fact that other stars are like the sun and they might have a planet like the Earth and therefore life around it that may have sinned and therefore Christ had to visit those places. That argument can be proven wrong if we find life on other planets, visit them, see that they sinned, and ask them if they witnessed Christ, and they say no. Then it's an experimental test of theology. But anyway, so coming back to your question, it really depends on what you define as God. Okay, and it varies between the theological version, which says, God looks over your shoulder and anything you do, is seen by God, and God responds to things that happen to you. And to me, that sounds more like the psychological equivalent of us as kids having a parent, because the parent always took care of us until we became adults, and perhaps the parents died, okay? And at that point, things happen to us that we cannot fully explain. And it brings you back to your childhood, where you relied on someone to take care of you in a way. So to me, that's a psychological need that is preserved from childhood. But putting that aside, there was the other version by Spinoza that argued that nature itself, is God in a way, and Einstein actually adopted that.
I see you have Walter Isaacson's biography of Einstein just beneath your book in your bookcase back there. Yeah, Einstein famously said, do you believe in God? He said, I believe in Spinoza's God, right? The laws of nature.
That's right.
Yeah, but that's
exactly.
But I assume you accept something like that. If there is a God, it's the laws of nature or something like that.
Yeah, I would accept, but I'll tell you one thing that I'm at awe with respect to, and that is the laws of physics we uncover through experiments on Earth seem to apply across the entire universe. And I find that amazing. My colleagues that work on cosmology say, okay, that's, to be expected. But to me, it's actually quite remarkable because, when I see my daughter's rooms in the morning, they look chaotic. And the laws that we establish on Earth, the societal laws, are not really being obeyed by some people. And so it's clear that it's not obvious that even if you find laws being enforced in some region of space and time, they would apply everywhere, and they do, and that's remarkable. The universe is organized in terms of obeying the same laws. It's also organized in terms of having initial conditions which were similar everywhere. There is a lot of beauty in the universe that could have been much worse, let's put it this way, and I'm at awe at that. And I should mention that I don't think religion is necessarily in conflict with science unless it tries to make predictions about scientific topics. And the reason I say that is if you examine, let's say, a watch, what the scientists are doing is trying to understand how the world works. And if you look at a watch, you can examine how it works. It's the same thing. You're trying to figure out.
Yeah.
And that doesn't say anything about what's the purpose and, the metaphysics, what is beyond the mere existence and operation of the world. And there is room for having some belief system on top of the scientific perception of the world. And by the way, there is a scientific perception of the world. There is also the artistic perception of the world, which is different, in arts, in the arts.
Yeah.
And I think it's extremely important to preserve that. A lot of scientists dismiss theology, like your friend Dawkins dismisses theology entirely. I think people have a need for that, and you cannot dismiss something that a lot of people need.
Okay, let's set aside for just a second the need part. Given your preeminence and what you do in cosmology, you must get theists and theologians come to you that say, well, what about the cosmological argument, the fine-tune argument, the first cause argument, the prime mover argument, and so on? How do you respond to those kind of arguments?
Well, I say that we have gained some knowledge about what the universe is, and I remember as a student there was a mathematics professor that said, he can find evidence for God in the text of the Old Testament by examining the repetition of a certain letter and then constructing sentences like the letter that appears in seventh place, and then you go another seven letters and find it. And you collect them, and it has some meaning, and that implication that the text was written by a divine entity. And then, my point is that, okay, that's one interpretation, but in fact, if you take a random text, you find that it's not really true that you can arrange for things that are coincidental. And so my point about the universe is we have scientific data, okay, and the advantage of it is we can get more clues about how things operate. Now, saying that there is God or not God, that is not really within the realm of physics, as long as you don't introduce God into the equations that physics deals with, right? So if you say it's on top of that, then I allow you to have your ideas, and there is nothing wrong as long as you don't make a statement about, like the text was written by a divine entity, or the motion of this galaxy was driven by some unnatural force, because that I cannot accept because we know all the facts about it.
Yeah. Your SETI colleague, Paul Davies, has this famous line from one of his early books that, I forget the exact wording, but it was something like it seems like the universe knew we were coming. Like there's a kind of a teleology to the laws of nature that drive toward something like consciousness.
Well, you have to be careful about that because we exist, and obviously what led to our existence was necessary for us to exist, right? So you can always say that, like if you end up taking the wrong turn in the highway and you end up in some neighborhood, you look around and you say, I'm in that neighborhood And in order to get to that neighborhood, I had to take that turn. Obviously, you wouldn't be there if you didn't take that turn. But that doesn't mean that the turn was intentional.
Yeah, that's the weak anthropic principle. The strong one is that it was driving us toward that direction. The forces of nature kind of lead to the rise of complexity in complex systems, and you get emergent properties, and the top of that is consciousness, sentience.
Yeah, so I don't believe that we are at the top of anything. I believe that we are as common as ants are on a sidewalk. Again, I have a very strong sense of modesty, and I don't think that we are particularly unique or special. And that's why I wouldn't say that the consciousness we have represents some pinnacle of creation or anything. Yeah. I would say, it's just an outcome, and it's everywhere, okay? Because whenever we thought that we are special and unique, we were proven wrong, just like my daughters before they went to the kindergarten. And that's why I start with the premise. Maybe it should be a new principle, in science, that start always from the premise that you are typical, you are not special. If you start from that and you end up finding that you are special, then you should be really happy. But it doesn't happen. Most of the time, it doesn't happen.
Yeah. What is your answer to the question, why is there something rather than nothing?
Well, that is a very fundamental question that we can ask the aliens when we meet them.
Yeah, right.
And
maybe they figured it out.
Suggest maybe. Yeah, so the thing that I mentioned before, making the universe in a laboratory would offer a possible solution. Another one would be if we had a theory of quantum gravity, we can then go through the singularity of the Big Bang and figure it out. But we don't have it. If the string theories were making a prediction as to what happened before the Big Bang, that would be nice.
Yeah.
That would be nice, because then we can perhaps test the theory in one way or another.
Yeah. Given your position, you must get these letters and papers that I get from, I call them theories of everything. These are, if Einstein was wrong and Newton was wrong and Hawking was wrong, and they usually spell it incorrectly. Feynman, they misspell it. But I've been working this out, and I'll share the Nobel Prize with you if you'll help me with the math. You must get these letters. I get them.
I get them, but I also get them. I also read papers that talk about theories of everything, and I wrote a Scientific American essay saying beware of theories of everything, because they could be theories of nothing. Actually,
right? Yeah, but what's interesting to me is that they're almost always by men. And it's almost always cosmology and astronomy. It's not like I've worked out a new theory of geology or plate tectonics. It's never about that. It's always like the universe.
I'll tell you why, because there is a lot of data in these other frontiers, and cosmology, suffered from a lack of data. By the way, an interesting anecdote is that the early universe was simpler than the present-day universe. We started with conditions that were uniform and then ended up in what we have.
Right.
And when I was a postdoc, I remember people saying, the only reason that the universe appears simple at early times is because we don't have enough evidence about it. Well, guess what? Now we have, and it's still much simpler at earlier times. So it was simple to start with.
Is cosmology not an example? Is cosmology itself not an example of where it was once kind of taboo to make that your field of study? Now it's pretty acceptable.
Oh yeah, it's not just cosmology. I can give you a more recent example. I worked on gravitational wave astrophysics before the discovery of gravitational waves, and in 2013 I gave a lecture at a winter school in Jerusalem about gravitational wave astrophysics. And 10 minutes into my talk, one other lecturer, who was a traditional astronomer, stood up and said, "Why are you wasting the time of these young students on a subject that will never be important during their careers?" And 2 years later, and by the way, this person that made the comment was much younger than I am. I will not mention the name, but much younger than I am, and just recently tenured. Okay. Now, 2 years later, when the students were still doing their PhD, the gravitational wave signal was detected by LIGO.
Whoa.
And on that, they received the Nobel Prize.
Right.
That just shows you how things can be ridiculed by a lecturer in front of all the students saying this, as if I'm wasting their time, when 2 years later it was discovered.
Yeah.
It keeps repeating this pattern, and that's what gives me confidence. I'm confident that based on my experience in the past, that when I promote a new frontier, like for example, I promoted the study of the first stars, there were only a few people worldwide that showed interest, and people were ridiculing that. And then it became a mainstream activity that now there are hundreds of people working on that, and that's one of the things that the James Webb Space Telescope will focus on. Gravitational wave astrophysics is another one. Imaging black holes is another one.
I ran across that.
From those experiences,
I ran across that title, not archaeoastronomy. What is it? Astronomical archaeology?
Space archaeology, you mean?
Yeah, I think you coined the term, right? Where like trying to find evidence of the first stars.
Oh, yeah. So that's right. That's what I worked on early on in my career. But my point is, from all these examples, you get a pattern. The pattern is that a new frontier or a new idea that is often ridiculed, and you may call it selection bias, but I witnessed it multiple times, and I didn't witness anything to the contrary in terms of what I worked on. So here is my forecast. The search for technological civilization, mark my words, will become a mainstream activity. I'm not sure exactly when, but once it becomes a mainstream activity, all the young people that work on it would say, what? There was a time when people didn't allow this to be discussed?
Yeah. Yeah, it reminds me when I was in graduate school in psychology in the 70s, no one talked about consciousness. Consciousness was like something New Agers do, the woo-woo people. And then Francis Crick came out with that book in the 90s, I forget the title now, but and then Christoph Koch, who's a neuroscientist, joined up with Francis Crick. And Francis Crick is like, oh, well, that makes it okay then. Right? And then they have a lab, and now everybody's writing books about consciousness and studying fMRI brain scans for consciousness. Exactly. That's a huge field now.
Exactly. No, so that's why we should think about the long term. And, I was in the military at age 18, and while in the paratroopers, I learned that sometimes a soldier puts his body on the barbed wire so that others can pass through. And I'm willing to suffer the pain, but I think it's for the young people of today so that they will be able to discuss it freely in the future. I do it as a service.
Well, I think you're pretty safe there at Harvard. I don't think you're going to be canceled. I think you're going to be okay. It's the younger people you're worried about, and I think that shift is coming.
Yes.
Avi,
hopefully.
Avi,
thank you so much.
We've been going almost 2 hours. I don't want to go all Joe Rogan on you, so I really appreciate it. This was a great conversation. I really appreciate you taking the time, and really thank you for your work. I loved your book, and
overall, I think, Michael, we agree on almost everything. It's just the nuances of how to communicate it, but on the fundamentals, I think we agree.
Yeah,
so let's hope for a better future.
Okay. We'll see you on the other side, wherever that is. All right, Avi. Thank you so much.
Bye.
Bye-bye.
Thank you.